In this video, we're going to use the chain rule to show that for real numbers a greater than 0 with a not equal to 1, the derivative with respect to x of a to the x power is equal to the natural log of a times a to the x. So for example, the derivative with respect to x of 10 to the x is the natural log of 10 times 10 to the x. And so the natural log of 10 is just a number. The natural log of 10 is approximately 2.303. And then that's times 10 to the x power. So remember that what natural log of 10 means is that because natural log of 10 is equal to approximately 2.303, that means that e to the 2.303 blah 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 is equal to 10. And both e to the something and natural log are really useful functions in a lot of the applied sciences. And further, if we think about the function y equals 10 to the x, remember that's an exponential function, so the output at 1 is 10, it's quite large. The output at negative 1 would be 10 to the negative 1, 1/10, very small. The output at 0 is 10 to the 0 is 1, and so on. So this is an exponential function. It's fairly steep. And if we thought about, what does it mean for, say, the derivative y prime is natural log of 10 times 10 to the x. Let's say that we want to evaluate the derivative at x equals 1, say. Then y prime at x equals 1 would be the natural log of 10, 2.303 times 10 to the 1 times 10, so about 23. That's saying that the slope of the curve at x equals 1, that slope is approximately a slope of about 23, a pretty large positive slope. Okay, now let's prove this rule for derivatives, that the derivative of a to the x equals natural log of a times a to the x for positive values of a that are not equal to 0. We're going to use a few facts. One is that we know that the derivative with respect to x of e to the x is just itself, is e to the x. Another fact we're going to use is the chain rule. The derivative with respect to x of f of g of x is equal to f prime of g of x times f prime of x, times g prime of x, sorry about that. Other facts we're going to use are just facts about natural log and e and how they are inverse functions. So if we think about the function y equals a to the x, one thing we can do is rewrite a as a is equal to e to the natural log of a, and that's again just because e and natural log are inverse functions, so they undo each other. And so then we're going to rewrite y as, instead of a, we're going to write e to the natural log of a to the x power. And so then we can rewrite that as e to the, now when we take the exponent of an exponent, we just multiply those exponents, so that's natural log of a times x. And so that means that the derivative y prime is equal to, all right, now we are doing a chain rule where e to the something is the outside function and natural log of a times x is our inside function. So the derivative of e to the x is just e to the x, so it's e to the, leave the inside function alone, and then times the derivative of the inside. Now remember, ln of a is a constant, so this is the same thing as if you were just taking the derivative of 3x. The derivative of 3x is just 3. The derivative of natural log of a times x is just that constant natural log of a. All right, so now we can continue to simplify this. So this was equal to e to the ln of a times x. We can do kind of the opposite of what we did up here. This is the same thing as e to the natural log of a to the x power times natural log of a, and then this is equal to e to the natural log of a. Again, these are inverse functions, so they undo each other. This is just a to the x power times natural log of a, and that's exactly what we're looking for, ln of a times a to the x, and that is our derivative with respect to x of a to the x for any positive value a that is not equal to 1. So a few things to note here. One is that this does agree with the derivative of e to the x. So if we just thought of e as just any number that is positive and not equal to 1, and we wanted to use that rule above, then this would be equal to the natural log of e times e to the x according to that rule. And what's the natural log of e? Well, the natural log of e, ln of e, that's the power that we must raise e to get e back. So that is just 1. The natural log of e is 1. So this is just 1 times e to the x, which is e to the x. So great. That agrees with our previous derivative rule that the derivative of e to the x is itself, and it and constant multiples of it are the unique functions with that property, or unique non-zero functions with that property. And if we wanted to take, say, the derivative with respect to x of 2 to the x, then that would be equal to, by that rule above, the natural log of 2 times 2 to the x. So natural log of 2 is a value that's just slightly smaller than 1. So we can just leave it as natural log of 2. That's a precise value, or we could say that that's equivalently or approximately equal to 0.693 times 2 to the x.